All right, good morning, everybody. Today we'll be presenting our project on the cost analysis of store-to-store transfers. My name is Alejandro Gonzalez.
I'm Zach Davis.
I'm Andy Bob.
And I'm Chris Kimball.
So I'd also like to include our corporate sponsor team of Chuck Reilly, Roger Freisleben, and Samantha Smith. We really want to thank you all for introducing us to this project and being there every step of the way. We really appreciate you guys. I'd like to start today with the problem statement that we tackled for this project. Now is to determine the cost and economic benefit of parts that are being transferred from one store to another. With this project, our goal was to lower transportation costs for the company and kind of see how we can maximize employee usage and reduce and eliminate any redundant costs that the company might be spending on these part transfers. But before we get to the data and analytics, I'd like to cover two key concepts that the company uses for their part transfers. The first is the hub run. And this is just the standardized way Advanced Auto Parts moves their parts from store to store from a central hub store. They use a third-party delivery driver, and a hub store is just simply a regular store with a larger amount of inventory. The other concept is the chase. There are two different types of chases. The first is the Hotshot Chase, and this is simply when the store sends out an employee in a company vehicle to retrieve a part to either restock in their inventory or to sell to a potential customer. The other is the embedded chase, and the embedded chase is simply just like a hotshot chase, just with the additional step of going directly to the customer after picking up the part from the second store. The time and distance between all these different points was very important for the analysis portion of our project. With that being said, I'd like to now pass it over to Zach to talk about the data.
Thanks, Alejandro. So throughout the project, we were able to get our hands on a lot of different data. And all of this data was very key for us to basically accumulate into one table so that we could perform a lot of analysis on this to determine our different costs for the different types of product transfers that we detailed. So first, the two data sets that I wanted to highlight is the store-to-store transfer set and the chasing analysis set. So the store-to-store transfer set actually was something that contained all of the transfers, so hub runs and chases that Advanced Auto Parts completed throughout whatever periods we looked at. So specifically, we looked at periods 9, 12, and 13. So it contained all the transfers for those periods. And then the chasing analysis set was something that contained strictly information detailing chases, which was the extra cost that we wanted to look at in terms of how much it was costing Advanced Auto. What was key here was we wanted to identify our chases within our store-to-store set. So we didn't necessarily have a way to identify which was which. And we were able to do that through the use of common columns between the two data sets and basically matching these records. So we could see if there was a match, it was a chase. If it wasn't a match, it was a hub run. In addition to these two data sets, we had 4 supplementary data sets that we used in terms of detailing our data a little more clearly in terms of the SKU list. So putting a part name to a certain part ID. So that was key in us detailing patterns of what sorts of items were transferred on hub runs versus chases. We had drive times and drive chases or drive time of chases. So basically how long it took us to move a part from one store to another, and also that mileage that it took us to go from one store to another, which was key in us determining our different costs for these transfers. Wage rate was something we wanted to detail also as we are sending a store employee out to make this chase. It's key for us to see how much we're paying that employee to perform this sort of task instead of their in-store activities as they should have been. And then the delivery standard is something Alejandro alluded to. This is that unknown amount of time that it takes us to go from store B to that customer. And this is something that we came to the conclusion with the AAP team with, and was an assumption that we thought was very useful in us in our cost equations. I'm now going to pass it off to Sakshi, who's going to detail our analysis a little more.
Thank you, Zach. So as Zach mentioned, we had a lot of data. We had about 1 million records in the store-to-store transfer file and a few 100,000 records in the chasing analysis file. So we decided it would make sense to sample the data, build our analytics process, and then move on to the bigger data sets that we had. We decided that the sampling would be done based on geographical locations, which is what Advanced calls DMAs. So we chose a rural DMA, which is the Roanoke-Lynchburg area, and we chose an urban DMA, which is the Raleigh-Durham-Fayetteville area. This was also helpful in us understanding how the frequency of chases and the parts that are transferred on these chases, how do they differ based on market conditions. Then the bulk of our analysis focused on calculating the cost associated with these additional transfers. And we had multiple discussions with Roger, Samantha, and Chuck, and we decided that there would be 3 components. There would be labor, opportunity, and fuel. So labor is basically the cost associated with sending a store employee out to go get a part. This is basically a store employee who's on the clock, who has certain tasks to do in the store, but will not be available to do those because they're out driving to get a part. The next one is opportunity. So we know, as Alejandro mentioned, hub runs are the standardized way of moving parts in Advanced Auto. So when they send a person out on a chase, we're basically wasting a part of this investment of this standardized way of moving costs. So that was going to be our opportunity cost. How much money are we actually not utilizing to get parts into stores? And the last one was fuel. As we know, this is a transportation problem and fuel is a rising cost. So we wanted to account for fuel in the total cost of chases. I'll now be passing it on to Annie to talk about the proof of concept.
Thank you, Sakshi. So we know that the chases happen for the pro customers. So even though they add up to a significant amount of the overhead cost, they might not be completely eliminated. So for that reason, we came up with a model that can be used by store managers to determine whether a chase should take place or not. So the model, we decided that the store managers should be the ones to use it, is because they're the ones who are dealing with the customers on a daily basis. So they know the needs and the wants of the customer. We have to keep in mind that this model only takes into account the profit and loss associated with the chase, but it does not take into account the relationship that the store manager has with their pro customer. So the way it works is that the store manager will have to enter the home store number, destination store SKU number with associated with the part and quantity. And then the output will be a predicted decision, which will be yes, no, or a manager's decision. So next will be our video demonstration, where you see here the manager will enter the home store number, which is their store. Next will be the destination store number, which is the store where they're going to go pick up the part from. And after that is the SKU associated with the part that they're going to chase. Then the quantity that they're going to chase. And then for this particular example, the response is a no, so the manager will not continue with the chase. Now I'll pass it on to Chris, who's going to go over the recommendations and wrap up the presentation.
All right, thank you, Annie. I'm going to wrap up the presentation by offering 3 key recommendations the team and I were able to come up with for the AAP organization. First is going to be a predictive model pilot that is driven by data. The overview of that would be implemented into a small sample of stores over a short period of time, anywhere from 4 to 8 weeks to help their decision making. Executing a trial of this capacity would help reinforce that this tool could save a significant amount of money. There needs to be a clear-cut decision-making method that says, yes, we can do this chase because it is profitable, and more often than not, it needs to be data-driven. So implementing this type of system would help regulate consistencies between stores and also lower those spur-of-the-moment chases. So in conclusion to this recommendation, it's emphasizing the cut of unprofitable chases. The next Annie spoke about for a quick moment, and we did not incorporate the relationship between customers and managers into our model. So that is a crucial and tangible variable that it's hard to really quantify in customer service and in retail, but we do believe that if that's implemented as a variable into the model, that it would help further accuracy. Finally, we would like there to be an expansion upon the information and the data related to chases. We were able to look at 3 periods spanning over approximately 12 weeks. We'd like to expand that to 13 periods over an entire year. We just think that that would reinforce our data further and improve accuracy. I'd like to thank everyone for being here today on behalf of my team and Virginia Tech, and we're going to open up the floor to any questions you may have.
When you were determining the window for what would and would not fall under manager's choice, how did you find the balance between statistics and the personal experience of someone who works in the field?
So the way we were able to basically figure out those kind of thresholds was we took a look at distributions based on the costs we detailed throughout the project, and there is basically a way to see a percentage of our chases fell within a certain threshold where we could deem it a positive return on investment in terms of making that chase. And then as we started to look throughout the distribution, there was a clear-cut kind of line where after about this X percentage, it wasn't smart to make that choice anymore. And then so there's kind of a cloudy part between that no and that yes, where kind of a rough percentage of data fell. So we were able to basically say that that was our manager's decision. Anything before that we could say is a no, and then anything after that we could say is a yes.
So I'm just curious, how did you guys include profitability? Was it a assumed level of profitability per chase, or were you actually looking at the SKU level, which
So that's a great question. So we made the assumption was any chase that we as a Advanced Auto made, we assumed that that was for a sale that we have already made for a product to a pro customer. So we could basically take that retail sales price that we sold the certain item for, and then that was something we worked down. So we have retail sales price, and then how much it costs a company to basically acquire that product, how much it costs them to hold it in inventory. And then within us basically detailing how profitable it was, we could then look at the different columns of costs that we determined in addition to those that were already incurred.
House in Roanoke affect your data? The distribution warehouse? Advance's largest distribution warehouse is in Roanoke, on the East Coast is in Roanoke. Did that affect your time and distance data?
There were a few stores which were going to, not stores, but warehouses. And for those, the drive distance and miles they weren't numbers. They were either greater than something or, between a range. So we weren't actually able to, we had to make an assumption for those particular records. We would just say, okay, this might be around 75 minutes. This might be around 60 minutes. Or if they were constants, it was easy. But if they fell in like a distribution of that sort, we would have to have discussions with the sponsor and then decide, should we actually include these or should we not? Because when we presented last week, like after we went through the whole presentation, they did say that the numbers you have are a little conservative. So the costs might be actually higher than the analysis that we ended up doing.
Sweet.
Thank you.